Okay, so new example. Now we have a word problem that we are trying to create a probability model for. So the Podunk Polar Bears, a football team, have 2 games left in their season. So far, they are winless. Experts estimate that the team has a 60% probability of winning the first game. If they win the first game, they have a 70% chance of winning the second game. Otherwise, there's only a 5% chance of winning the second game. This may start to sound a lot like a tree diagram problem, and it is, but our end goal is we're going to construct a probability model for the number of games that the polar bears will win. So a probability model is a table. Normally up to this point we've been given the table, but now we're creating the table. So in that table we could potentially have how many wins? Well, we could have the polar bears continue their streak and win 0 of the remaining 2 games, and that is an option. Another option is they could win 1 of the remaining 2 games, or they could win 2. And those are our options, so 0 or 1 or 2, and what our job is to figure out what are the probabilities for those 3 options. And in this particular problem, the way that we're going to find those probabilities is by creating a tree diagram and looking at the numbers. So that's what we're going to do. So if you go ahead and look at the 2 variables in this case are winning or losing the first game and winning or losing the second game. So for the first game, we could either win it or lose it. Right? So if we win the first game, we lose the first game. And so the probability, according to our experts, of winning the first game was 60% or 0.6. So that means using our simple complement rule, the probability of not winning the first game is 0.4. So that's the first part. So then from there, whether they win or lose the first game, they could either win or lose the second game. Okay? So according to our experts, if they win the first game, probability of winning the second game was 0.7, which means the probability of losing the second game is 0.3. Okay? If they lose the first game, the probability of winning the first or the second game was 0.05, 5%, which means the probability of losing the second game is 95%, pretty likely. So then we do our multiplication to find our 4 different options. So the first option, of course, is that they win both games, so 0.6 times 0.7, which is 0.42. So the probability that they're going to win the first and the second game is 0.42. Winning the first game but losing the second, 0.6 times 0.3 is 0.18. So first is won, second is lost. The third option is if they don't win the first game, but they come back and win the second game. So 0.4 times 0.05, which is 0.02. And then the last option, they lose both games. 0.4 times 0.95 would be 0.38. And what we have here are options. That first option, they won 2 games. They won the first and the second. So 0.42 is our probability that they won both games or 2 games. And the middle 2 are winning 1 game. First but not the second, not the first but the second. So adding those 2 numbers together will give us a probability of winning both games, or I'm sorry, 1 game. Okay? And then the last option is they don't win any, so 0.38 is our probability of winning 0 games. So if we put those numbers into our table, 0.38 was 0 games, 0.2, which came from 0.18 plus 0.02, is winning 1 game, and then 0.42 was our probability of winning 2 games. And then from that, if we wanted to, if we were asked to, we could find the expected value for the number of games, and we could find the standard deviation and the variance, okay, of those number of games by using those formulas that we learned before. Okay. So moving on to the second problem, and actually I'm going to take a pause here.